Certain types of questions on Maths Olympiads and JEE Main use Vandermonde's identity, which is this rather horrific looking thing. But in actual fact, once you get used to knowing how to use it, some of the questions, not all, some of them are fairly straightforward. Now the thing with this is what we're actually trying to do is when we have two combinations, nCr or whatever, multiplied together and summed, we can simplify that into one combo. And basically what you need to do is you need to get your summation into this form here. And what we need to do is we need to look at, so k needs to go from 0 to r, and then we have one of them is mck and the other one is mcr minus k. And as long as we have these four elements here, then we can simply add m and n together and put r there, and the answer is m plus n cr. Now, if that doesn't make any sense, let's go and do some questions. So this first one here, let's try and keep the formula in the picture. This first one here was from the JEE Main, January 2023, shift 1. So find the value of, so the sum between k equals 0 and 22 of 22ck, 23ck. Okay, now using nCr equals nc n minus r, okay, this one here we can rewrite as 22c 22 minus k, and then if we fill in the rest of it, 22 k equals 0, 23ck, we actually now, this one's a very simple one, we now have all of the criteria. We have the k equals 0, we have the 22 minus k, we have the k, so we have these three elements here, and we have the r, which is 22, which matches, and then all we have to do now is simply add up these two numbers here, which gives us 45c 22, and that is the answer to the first one. Now they get more complicated from here. That one was an easy one, admittedly. So let's have a look at the second one. Okay, now the second one here, this is a horror show, and this is a really tough question if you do get this, but anyway, they've got to be done. So this is the sum between k equals 1 and 31, so the first thing we've got to note is that's not from 0, it's from 1. 31k, 31ck, 31ck minus 1, minus another series is between 30 and k equals 1 of 30ck times 30ck minus 1 equals this. Now first of all, what we have to do is we have to simplify this and get it in the form where we can use the Vandermonde identity. So let's just let p equal k minus 1, so therefore k equals p plus 1, and then we can rewrite this here as the sum between p equals 0 and 30, obviously that goes down by 1 and that goes down by 1, of 31c p plus 1, 31c p. I've just replaced the k here by p, and then with this thing here we can say that equals the sum between 30 and p equals 0 of 31c 31 minus p plus 1. I'll just explain what I did there in a second. Cp, all I did there was I used nCr equals nc n minus r for that little adjustment there, and then that equals the sum between 30 and p equals 0 of 31c 30 minus p 31c p, and we now again have it in the right form. We have the 30, we have the 30 minus p, we have the p, and we have the p equals 0, so we have everything correct. So this one here we know is 31 add 31, 62c 30. So that is the answer to that bit, is 62c 30. Okay, now let's have a look at the second bit. Here is the sum between 30 and k equals 1 of 30ck 30ck minus 1. Well, by a very similar argument, we are going to be able to, that will become the sum between, by using again p equals k minus 1, that will become the sum between 29 and p equals 0 of 30c p plus 1, 30c p, which again will be the sum between 29 and p equals 0, again using nCr equals nc n minus r, 30c 29 minus P, 30C P, and then we now have that in the form again where we have P equals 0, 29 minus P, P and 29, we have it in the right form, so therefore that equals C 60, which is that one, add that one, 29. And so therefore this rather horrific looking expression we can now simplify to being, what can we simplify it to being? 62C 30 minus 60C 29, and we need to put that in the form alpha times 60 factorial times 30 factorial 31 factorial, and then it asks us rather bizarrely what is 16 alpha. So now we've done the hard part, so now all we got to do is just get this, so we can do 60, so 62C30 is 62 factorial over 32 factorial 30 factorial, and we've got to take away 60 factorial over 31 factorial 29 factorial, and we got to, let's put it in their format now, so that's 60 factorial over 30 factorial 31 factorial, which is what they want here. They want us to take that out and they want us to find alpha. So that's 60 factorial over 30 31 factorial, 62 times 61 over 32 minus 30, that's just taking the factor out of there, and so therefore alpha is that, and they want us to find 16 alpha. And again, this is a really hard question because you've already done so much work, and there's still only 1 mark, but basically, so 62 times 61 minus 30 over 32, they want to find out what 16 times that is. Well, 16 times that is 31 times 61 minus 480, which equals 1891 minus 480, i.e. equals 1411, which is 16 alpha, which is what they wanted. Now, in actual fact, this bit down here is just simple simple adding and subtracting of factorials. The hard bit is doing this bit here and using the Vandermonde identity. Okay, so that's question 2. Now question 3, sorry, if anybody wants to have a go at this, I'll pause the video now. Okay, so basically, let's have a look at this. So it's the sum between k equals 1 and 10. Again, we got this problem of k equals 1. And again, they're not making it easy for us. They're saying it equals 22,000 L. What is L? Okay, so we can rewrite this here as the sum between 10 and k equals 1 of k times 10ck squared, just basically putting it all squared. And then using nCr equals n over r n minus 1c r minus 1, we can say that 10ck equals 10 over k 9c k minus 1, and we can put that into there, which then gives the sum between 10 and k equals 1 of 10 times 9c k minus 1 squared. Okay, so and now we can take out the 10 squared, so that equals, because 10 squared obviously is a constant, sum 10 k equals 1 of 9c k minus 1 times 9c k minus 1, because it's squared. Okay, and so again, now we can use Vandermonde's identity, because we have a combo times a combo and we have to sum it. So again, we'll use the same trick. Let's let k equal p plus 1 or p equal k minus 1, and that's going to get us our p equals 0. So that equals 10 squared, the sum between 9 and p equals 0 of 9cp 9cp, and again using nCr equals nc n minus r, we can write that as equals 10 squared, the sum between 9 and p equals 0 of 9cp 9c 9 minus p, and we now have it in the correct form to use Vandermonde's identity, which means that equals 10 squared times 9 plus 9, 18, 18c 9. Okay, now the question also asks us a little bit more though. It says that equals 22,000 L. What is L? So 22,000 L equals 100 times 18c9, which is 18 factorial over 9 factorial 9 factorial. Again, they're not making this easy to get your mark here, but that means that 220L equals, and that 9 factorial factors out, that leaves us with 18 times 17 times 16 times 15 times 14 times 13 times 12 times 11 times 10 over 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Again, if you had a calculator, just do this with a calculator. But if you don't have a calculator, and a lot of these exams are not calculator exams, unfortunately we have to do it this way, where we're basically just cancelling out factors. And that leaves us with... basically, that leaves us with 220L equals 17 times 2 times 13 times 11 times 11 times 10, i.e. L equals 221. And that's the answer to that one. But again, the hard bit was using the Vandermonde identity to get the answer of 18C9. Okay, that's that question. Now this question here is the fourth question, as promised. Okay, so if anyone wants to do that, just pause the video. Right, now this one, if we didn't have this little constraint here, I not equal to j, then basically this is equal to nc0, so letting I equal 0, times nc0 add nc1 add nc2 add ncn, add nc1 times nc0 add nc1 add nc2 add ncn, add ncn times by nc0 add nc1 add ncn. That's basically all of the combinations of I and j. And then if we factorise that out, we will find that it basically equals nc0 add nc1 add ncn times nc0 add nc1 add ncn. And that the sum of that we know is just 2 to the n, and the sum of that is 2 to the n, which gives us 2 to the n times 2 to the n, which equals 2 to the 2n. That is if we were allowed for I equals j. As we are not allowed for I equals j, we have to take out nc0 times nc0 and nc1 times nc1, blah, 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 and ncn times ncn. So we have to actually take out nc0 times nc0, add nc1 times nc1, add ncn times ncn, and that is the sum between n and k equals 0 of nck times nck. And here we go, we almost have our Vandermonde again. All we need to do is use nCr equals ncn minus r, and that is the sum of n k equals 0 nck ncn minus k, and now we have it in the right form for the Vandermonde, and so therefore that equals 2ncn, just n plus n, and the n comes from there. And so therefore the answer to the question here is basically what is the sum of all that I not equal to j. It's 2 to the 2n, so the answer is 2 to the 2n minus 2ncn, and that is the answer to that one. Okay, now for anybody who is not brain dead by this part of the video, and there's a little bit of a cool stuff for you using Pascal's triangle. Just looking at this thing here, 2ncn. So let's just I've just drawn this Pascal's triangle here. So let's have a look at 2ncn, which equals the sum of what's it equal the sum of? Sorry. Equals the sum of between n and k of equals the sum between n and k equals 0 of nck nck. Okay, well, what does that actually mean on Pascal's triangle? I think you're going to like this. What it means is that if we take any one line, and let's just take that line for example, that's the n equals 4 line, which would be this side of the equation, and basically we sum, so nc0 times nc0, add nc1 times nc1, add nc2, add nc2, all the way up to, so we'd add that there, squared, add the next one, 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 squared. That's what that is saying. They're saying that it equals 2nCn, which would be, in this particular case, equals 8C4. Well, where is 8C4? 5, 6, 7, 8. N equals 8. Well, 8C4 is 70. So does it equal that? 1 add 16, 17, 34. Well, it does. Hey presto, equals 70. So if we just want to check it with another one, if you had, say, n equals 3, then 1 squared add 3 squared add 3 squared add 1 squared is 20, and that would therefore be equal, because that would equal 6C3, and 6C3 is there. 6C3, hey presto, equals 20. So there's a little bit of a cool trick for you in Pascal's triangle, but that is what that actually means, and that is a use of Vandermonde's identity for party tricks, if you happen to go to parties where they discuss this sort of thing. Anyway, anybody who's found that useful, please subscribe to the Gresty Academy YouTube channel. Thank you very much.